What does? Bunch of weirdos. Oh, we should write the full date because it's neat. You ready? Today is 1/23/23. That's what my watch says. Yeah, it's 1/23/23. That's pretty cool. Or as the hip kids say, that's pretty dope. So what you guys did last week was systems of inequalities, linear inequalities. We're going to shift it a little bit here for a few days and do systems of equations. So we call them linear equations. Quite frankly, you won't see any systems of nonlinears until, I don't even know if we still do it in Algebra 2. I think we do, we touch on it, but like where do curves cross each other? But these are straight lines. And so linear equations, of course, refers to straight lines. So a system of linear equations is generally two. Put your phones away, please. So it's generally two equations. And what we're going to do today is learn how to solve them by graphing. But in coming days, we're going to learn to solve them without graph paper. Ask anyone that teaches algebra, there are three ways we teach you to solve systems. One of them is called graphing. The other two are what we call the algebraic methods. Algebraic methods, that word means we're not using graph paper, we're not graphing lines, anything like that. It's strictly manipulations of X's and Y's. Anyhow, so let's take a look. I would have to start this lesson really quickly by talking about lines. And so if you think about graphing two lines on a piece of paper, the same graph, if I gave one piece of graph paper to Bryce, and I drew one x-axis and one y-axis, and I gave him two linear equations, and I said, hey, Bryce, would you graph these for me? There are exactly three things that can happen. One of those things is that the lines can cross like this. I hope you would agree with that. In a case like this, we say that there is one solution, and that solution occurs right there where that blue dot is at. So again, that, I want to be clear, is called the solution. And what that means is that if you took the x and y coordinates of that point and you put them into both equations, they would both work. Like one equation might say 4 = 4, and the other equation might say 10 = 10, and you're like, wow, that works. So for a point to be on two different lines at the same time, it can look like that. All right, so I'm not interested in like this yellow point or this green point. Those points are no good because they only solve one of the equations and not both. Okay, so that's what we're hunting for here, is the crossing point. And being good at graphing lines, like I think we are, then this should not be an issue. What are the other two things that could happen if Bryce graphed two lines on the same piece of graph paper? They could be parallel to each other. Very good. That's usually the one that people come up with next is parallel. And so if I gave Bryce a piece of graph paper and he graphed two lines, who's to say that they won't look like this? And in a case like this, these lines literally never cross each other. So if I send you on a hunt to say, hey, find me the point where the lines cross, you're like, I can't do that because there is no crossing point. Like it just does not exist. So what do you think we say about a system like this? Not undefined. That's a word generally referred that we use to refer to like a slope of a vertical line. It's like a number that doesn't exist, kind of. What is this? There is no solution. That is what we say. Very good. So those are two possible things that can happen. It's this third one that's a little bit more obscure. But there is a third possibility, and it's completely weird and a little bit like, really? Does this actually happen? But it can. You think of what it is? How would that happen, Mari? How could we have infinitely many crossing points if they're straight lines? Very good. Yes, exactly. That usually that answer doesn't come out that quick. Good job. That was really quick. Thank you, Mari. So what can happen is you can look at two equations and they might be did I already resume the recording? Did I? Okay. So yes, that's a very good thing for you to have said. And it may not, it sounds weird. Like, why would anyone graph two lines that are exactly the same? Well, they may not look the same. So like I might give you an equation that's in standard form, like 3x plus 2y equals 6. And then I give you another one that says like y equals negative 3/2 of x plus 3. And you don't know at first glance that they're actually the exact same equation. And then you get to graphing them, and you're like, well, I'll be darned. And so what would happen is Bryce might put his pencil down to graph a line and say it goes like this. And, he graphs the line and he's on his way. And then I give him a second equation and he graphs it and it goes like this. And he realizes, like, hold on a second. I just copied over the same line. And Mari nailed it. She said exactly the right words. This has infinite solutions. You're not allowed to say all real numbers. It's one of the most confusing things as we go through Algebra 1 and Algebra 2 is knowing the difference between saying all numbers work and infinitely many numbers work. And it's like, how could those not be the same? Well, they're just not. I mean, like, think about it. Like if Bryce graphed these two lines, like, is that a solution, that yellow dot? No. And I could do that all day. I could keep finding points that aren't solutions. And so that proves the point that all real numbers are not solutions. But we could also then make the case that there are infinitely many points on a line, which is why, again, like Mari said, this system would have infinitely many solutions. So those are the three things that can happen when you graph two lines. Today's assignment is, I think, entirely going to focus on this first one. And that is, there is one solution. Okay, clear? So as we go through the next week or so and we look at systems of equations, you'll start to see more, when we get to the more algebraic methods, you'll see more and more of these parallel and overlapping lines. But for today, I think it's just going to be a focus on graphing two lines and through inspection, just looking at them and saying, oh, I see where you cross. It's a pretty simple endeavor. So I'm going to use Delta Math for today's lesson because it really is just the most sensible way to do this. So there are two levels that you're going to be faced with today. There's level 1 and level 2, and don't worry about your Chromebook just yet. Okay, there'll be plenty of time. So why is this pretty attractive to us? Like, you've been around the block a few times. Why is graphing that going to be like a breeze? It's already in y equals mx plus b. And like graphing, just math doesn't get any easier than graphing a line that's in y equals mx plus b. So let me show you kind of the interface and then we'll do a level 2 problem together. And honestly, that's it. It's pretty simple stuff here. We put in a lot of work before this that's going to enable today to be so easy, right? So where would I start this first graph at? Down 6. I'll put a point at down 6. And what is the slope? So describe that to me. Couldn't have said it better myself. Down 1, right 2. So I click and there's a line. Okay, now it's going to wait for me to do line 2. Where will I start line 2? At up 6. And what's his slope? 1. 1. What does that mean? Up 1, up 1. Thank you. Up 1, right 1. Remember, the word over around here gets you busted, right? You know that about me. And all math people should feel that way. We hate ambiguity, like we hate not knowing what someone means. So up 1, right 1 is perfect. And now all I have to do is through inspection, just eyeball this point. And you can clearly see, I hope it's big enough for you. You got good eyes. What's the name of the point where they cross? Perfect. I mean, you can literally see the point where they cross. It's -8, -2. Don't get your X and Y backwards, okay? You shouldn't be having any issues with that. So the solution, we're going to use parentheses because we're doing an ordered pair, and we're going to put in -8, comma, -2, close the parentheses. And that's really all the level 1 problems want you to do, is graph a couple of lines in super simple form and observe where they cross. Easy enough, okay? So here's a level 2. And these, I mean, in my experience with this, what I find is they give you one that's in slope intercept and one that's not. So there's a little bit of work that you have to do here, but it's not a lot. Let me get my pen back here. So we'll do a red pen. Obviously, this equation is the one that needs work, right? So how are we going to get y by itself? What would our desired equation say y equals? Yeah, perfect. It's a very limited amount of work that you have to do. And now you're like, oh, it's just back to being a level 1 problem. So like you would graph the first line. What's his starting point? Down 5. What's his slope? 2. Use, what does that mean for me? Well spoken. Up 2, right 1. Just click, boom, you got a line. Now our second equation is this red one over here. Where's his starting point? Down 8, right? And what's his slope? Down 1, right 1. And then you observe the crossing point. And what is the crossing point? Right. There's very few mistakes that can happen with this. Number one is if you're still struggling with slope, you got to be done with that. You got to go say goodbye troubles with slope. I'm done. It's January 23rd. I'm done. Never going to miss another slope again. And the other thing that could happen is you could get your X's and Y's backwards. So remember, when you name the point, it's X and then Y. So that's all you got to do. You guys have any questions about that? I got a real short assignment in Delta Math. You'll totally have some free time when you're done, so I'm okay with that. So let's get her done. It should have posted itself a few minutes ago.